Well, welcome to the Cornish and Plainfield Energy Committee's continuing education series presentation on home battery systems. I am Steve Ladd from the Plainfield Energy Committee, and I will be the moderator for tonight's event. We are fortunate to have 4 guests with us to talk about home battery systems and various residential storage topics. Unfortunately, Kim Quirk from Revision is unable to be with us tonight, but Tom Hobbs, the residential sales team manager from Revision, will present an overview of residential storage and touch on topics like grid tied versus off-grid storage system, sizing a battery system, and how different rates of utility programs could use storage to make the grid more resilient. Tom is a graduate of the University of New Hampshire, and after completing an internship with the New Hampshire Sierra Club, Tom knew he wanted to get involved with clean energy. At Revision Energy, Tom has been involved with managing the warehouse, helping out in installations, and designing clean energy system. He is now a residential sales team manager and has a broad depth of knowledge on complete energy systems. After Tom, we will hear from Chris Sparadeo, the off-grid division manager at Catamount Solar. Chris will go into more detail on AC coupled and DC coupled battery storage systems and outline a few manufacturers' offerings. Chris is a certified PV installation professional and system inspector, as well as a licensed electrician. He is Catamount Solar's off-grid specialist and has designed hundreds and installed hundreds of off-grid battery-based systems and has hands-on experience with the majority of the battery-based offerings available. Following will be Brian Callnan, who is the first Chief Executive Officer of the newly formed Community Power Coalition of New Hampshire. Previously, he was Vice President of Power Resources and Access at the New Hampshire Electric Co-op, responsible for managing the cooperative power resource portfolio and load flexibility strategy. He has over 20 years experience in energy efficiency valuation and systems design in all aspects of power supply and transmission. Brian will explain the importance and benefits of transactive energy and bidirectional EV charging. Tony Newton will wrap things up with a comparison of a few batteries, including the differences in chemistry, composition, solar input requirements, backup duration, and costs. Tony is a retired systems analyst and an avid do-it-yourselfer. He has built a number of off-grid systems and enjoys doing the research necessary for building energy-efficient electrical systems. Each of our guests will give a 10-minute presentation, which will allow us plenty of time for Q&A at the end. We ask that you please hold all questions until the Q&A session at the very end of all the presentations, and please, 1 question per participant. We will not be using the chat platform, so please don't send your questions to the chat box. Instead, use the raise hand feature. And if you're not familiar with the raise hand feature, you bring your mouse or pointer to the bottom of the Zoom screen and click on the reactions button. Click on the raised hand. It's the wide bar under all the emojis. This will show a yellow hand in the upper left-hand corner of your individual Zoom rectangle. This will place your personal rectangle at the top of the screen in order of who raised their hand first. You will then be recognized by the moderator to ask your question. So let's get started with an introduction to residential storage systems. Tom?
All right. Audio coming in clear. Does that sound good? Excellent. Thank you so much, Steve. Let me share my screen here and kick us off. And if I could just get a quick thumbs up from anyone in the crowd that they can see this. Excellent. Thank you so much. So again, my name is Tom Hobbs. I am an employee owner at Revision Energy, filling in for Kim Quirk tonight. Or I should say I'm going to try to fill in for Kim. If you've ever heard Kim talk before, she is amazing and I'm going to try my best, but definitely would recommend listening to a Kim Cork presentation if you can. So just a brief background in Revision Energy. We are an employee-owned company. You heard me mention, again, being an employee-owned, employee owner. So we have been an employee-owned company since 2017, and here we have a nice company photo of us. We're roughly about 450 co-owners at this point, with offices in Northern Maine, in Portland, in Brentwood, New Hampshire, in Enfield, New Hampshire, and then in the North Shore of Massachusetts as well. We've been in business for about 20 years and have just become an employee-owned company again for the past however many years at this point now. We are also what's known as a B Corp, so a certified B Corp. That is a certification for for-profit businesses that want to use business as a force for good and diversify themselves from traditional businesses that just want to focus on maximizing profits. So we like to reinvent business and think about it in the triple bottom line of people, planet, and profits. So we need to have profits. We need to have money in order to make the mission work. But what we do with that is invest it again in our people and in the planet and everything that we do. And what is our mission again? To transition Northern New England away from fossil fuels and to a clean energy economy. And how we go about doing that is through the installation of the services that we offer: residential, commercial, and municipal rooftop and ground-mounted solar, community solar farm initiatives. And as I'm really focusing on in this graphic here is the 100% solar household, where we try to identify opportunities for electrification through the installation of domestic hot water systems, using heat pump technology, ductless heat pump systems. What we'll talk about in just a minute here, the primary focus, solar battery systems, electric vehicle charging systems as well. So offering that whole home package to help homeowners and communities transition to electric means of energy. And when we talk about solar batteries, where we really like to start the conversation is between power and energy. So what are we looking at here? Power is the flow of electricity. So we measure that in watts and most commonly kilowatts. And when we talk about energy, so that is the quantity of electricity that can be provided over time, commonly measured in kilowatt hours. So nice example there, a 1 kilowatt or 2 kilowatt hour battery can provide 1 kilowatt of power for 2 hours. We'll get into a little bit more of that, but some examples of that. So we think about a 0.4 kilowatt, again, power refrigerator is on for about 6 hours a day, and that's going to use about 2.4 kilowatt hours or energy each day. And when we think about how that relates to solar and battery systems, we talk about a 10 kW power solar system that could produce upwards of 30 kilowatt hours, again, energy on a sunny day. So how does that all kind of play into what we're talking about here? With solar batteries, we're looking at this as, again, emergency battery backup. And in the example of grid outages, what are those options that we currently have available to us? So generators, the traditional portable pull-out generator that you're running an extension cord to your house and filling up with a gas can, or your more solid, larger scale automatic generator there, in comparison to one of the most standard battery offerings that you'll see out there, the household name Tesla Powerwall. What are some of the differences between all of these options? Well, your generators, again, those are usually the most cost-effective to install, at least up front, and they can power the entire house. Those are some of the major benefits of a traditional generator. Disadvantages we see, they're using fossil fuels. That fuel is limited. The operation of the systems is quite loud, and it's going to use fuel even when the demand for electricity is pretty low there. With a solar battery, what are the advantages where we see there? It's going to be relatively quiet. It's going to be fast. It can be charged with solar, either on the rooftop or on the ground at your property. It's going to be pretty smart in its technology and the features that it's using, and it can integrate with the grid as well. Disadvantages, and probably the biggest barrier to adoption, is just the greater upfront cost. Some of the loads that we're maybe used to powering with a standard generator, heating, for example, that may have to be shed and not available in its operation. So how do we go about designing battery system? That's really what I'm going to focus on in my presentation here. How do we size a solar battery system? So we like to start by taking a look at your electric usage and analyzing what trends we're seeing here. This is a nice copy of my electric bill here, where we can see I'm using more electricity in the summertime than in the winter time, mostly just due to air conditioning and that demand there. What we go through the process of is, again, identifying all of the loads in the home. So what are we looking at? What do we have in the home? And then from there, determining in our battery design, what loads are we protecting, or what loads do we want to shed, and how do we go about proceeding from there? At that point, identifying, again, protected loads. What are some common loads that we protect, what we consider the essential loads of battery backup? We think about your refrigerator, your well pump, some lights or outlets in the home, and in most instances, your router or your internet connection. And some loads that we typically shed or don't have powered by a battery system are what we consider some of the non-essential loads, such as electric heating or cooling, as we can see in that image of a heat pump up there, electric washers and dryers, electric ovens, ranges, your pool pumps, your hot tubs, your electric vehicle chargers. The majority of these loads, if not all of them, can be considered non-essential and just not needed during a grid outage. So they could be shed in a battery system where they're not being powered during that grid outage. And getting into a little bit more of our product offerings at Revision Energy, we have been installing Tesla Powerwall products since their inception. I believe we've installed upwards of 800 battery systems in New Hampshire, or excuse me, in northern New England, and just over 200 in New Hampshire at this point. And we're proud to soon be offering, or I should say now offering, the SolarEdge home battery system in our lineup, which SolarEdge is another manufacturer that primarily specializes in the manufacturing of inverters, solar inverters, and we are now offering their product as well. Brief overview into some of the operations of those batteries as well. So with a Tesla Powerwall 2.0 and a Powerwall Plus, which I can answer more questions on, but given brief overview here, options that you could see for going between different modes with the batteries. We talk about backup only, where we're keeping the batteries charged with solar and ready for battery backup. We have self-powered, where it's going to use solar and then the batteries for the home loads. And then advanced modes to operate on time of use programs, which excited to hear a little bit more about from one of our other presenters. And oh, I believe I might have skipped over one of them. Let me see. There we go. Sorry about that. Talking about SolarEdge and their battery modes, we have a maximum self-consumption mode where you're using as much solar as available to power the home, and then minimizing the reliance on the electric grid. Again, time of use, which I talked a little bit about, where we're maximizing the savings when those programs are available. And what we see the majority of our battery systems operate in, whether it's SolarEdge or Tesla, backup only, where you're managing the battery at full capacity to keep the lights on when the grid is down. So the common questions we get asked are, how long will my battery last? And in short, it really depends. What does it depend on? Well, it depends on the design of the system and what we're backing up there. So with the essential loads, which again, your refrigerator, your well pump, lights, outlets, and a router or internet connection, we have found throughout our process of designing and installing that we can usually have a battery system last for about 2+ days. And when we start adding some more loads into that, so in addition to the essential loads, your heating systems, so a typical oil boiler or pellet stove, we can typically get over 1 day of battery backup. And again, about a third of a day for the average American household using right around 30 kilowatt hours a day. Again, all just averages there. And then how much does it cost? Again, it all depends, but the most commonly installed solar battery system that we put in homes is a 2-battery system, whether Tesla or Powerwall, or excuse me, Tesla or SolarEdge. And that typically ranges around $30,000 prior to incentives, which the major incentive there is the federal tax credit, which at a $30,000 project cost would have a federal tax credit of $9,000, reducing that net cost to approximately $21,000 after incentives. I talked in detail about the incentives, but what we will see here is with the passage of the Inflation Reduction Act, we have a 30% federal tax credit for the foreseeable future. That is applicable for both battery installations and solar installations. So those federal incentives are backed and will be available for the foreseeable future. And we offer solar financing at Revision, working through a variety of different lenders, both local and national lenders that can offer varying loan options depending on the goals for homeowners to try to, again, overcome that initial barrier, the upfront investment in a battery system. And just a brief, real plug on what we do at Revision. Again, I talked about the 100% electric household. So in addition to battery systems, we're installing the ductless wall-mounted heat pumps, as we can see in images there with the condensers on the outside. Heat pump water heaters, electric vehicle charging systems. We, again, try to help homeowners achieve their energy goals. And that is going to do it for me. So I just want to thank everyone for attending this. I appreciate your interest in this.
Well, thank you very much, Tom. Chris, you're up next. And be sure to unmute yourself. There you go. Great.
All right, can people see my screen?
We can.
Great. All righty. Well, my name is Chris Sparadeo. I'm a member owner of Catamount Solar. We're a member-owned cooperative as well. We've been around since 2011. I am a NABCEP certified PV installer, system inspector. I'm a licensed electrician, an all-around solar nerd. I got my start in 2011, designing off-grid autonomous systems in very remote areas in Central America, specifically on the coast of Nicaragua. So I am very familiar with off-grid battery sizing, and as you know, battery, or I guess PV, and now PV plus storage is really developing in the market here locally in Vermont and New Hampshire. It's looking more and more like off-grid battery sizing, which is something that is kind of second nature to me. So today I'm going to speak to a few different system configurations, maybe some of the pros, some of the cons of those configurations. And then I'm going to give an example of a battery and an inverter that we commonly use, and talk about, you know, system functionality. So people are probably familiar with kind of the solar inverter and the solar panel side of solar PV. This is what a typical grid tied system may look like. So your solar panels produce power in DC and direct current. Your solar inverter, it's also called a grid tied inverter or grid interactive inverter, is essentially a one-trick pony. It takes that DC power and transforms it to AC power. Now on the battery side of things, the idea is that for an AC coupled system, which you could think of as like a grid tied inverter plus, you know, you name it, your flavor of AC coupled battery. So a Tesla Powerwall is a great example. What the Powerwall will do is it takes that AC power input from the grid tied inverter and will convert it back to stored DC power. So all battery storage in general, I mean, there's a few very rare, other batteries out there like flywheel and capacitors essentially, but every other battery on the market, anything that can store power, stores it in DC. So the idea with an AC coupled system is you're taking the DC of a solar panel, converting it to AC via your grid tied inverter, and then converting it back to DC via the inverter inside your AC battery. There are a few, so the pros of this scenario are that it's a great retrofit. So most people that have solar, there's huge solar boom in like 2013 up until presently that just didn't have battery attachment. This is a great option for people that are wanting batteries with their existing systems. Retrofitting an AC coupled battery is fairly easy, and it's cheap. There are some issues with this system configuration, one of which is that it's really tough, like specifically a Tesla Powerwall can't integrate a generator very well because there's only one AC input. And the idea is that when a generator is running in an off-grid, or sorry, in a grid outage scenario, you want to make sure that the solar array is isolated. So in effect, if there's a grid outage and you need to recharge your battery via a generator, because let's say the sun's not cooperating, there's 3 feet of snow over your solar array, you essentially need to disconnect your solar array in order to charge via the generator. It's not a very eloquent way of doing things. So I would suggest if you're looking for multiple charge sources, you have a generator, and this is maybe a new installation, that an AC coupled system is maybe not the right fit for you. The other issue with an AC coupled system is that your battery and the multi-mode inverter in the battery is kind of driving the ship. It's telling the solar when to and when not to charge the battery to make sure that it's not overcharged. The battery, it's very important that it's not overcharged because that would cause damage. So the way that an AC coupled battery inverter will do this with a grid tied inverter is something called frequency shifting. And this is essentially changing the way the power output of that battery looks to the inverter to turn it off. Many people are kind of surprised when they hear that a grid tied inverter without a battery, when the grid goes down, that PV system turns off as well. That is baked into the design of a grid tied inverter, and that is for lineman safety. The idea is that when the grid is down, your solar is down as well. So what the battery is doing is essentially tricking the grid tied inverter into thinking that the grid is present in a battery backup scenario. And when the battery is full and can't receive more charge, it's going to also trick the inverter, the grid tied inverter, into turning off because it doesn't want to receive more power. So the way it does that is it changes its frequency up to a level that will fault the inverter. The inverter is going to turn off by design for 5 minutes, wait, and then try to reconnect. If the battery is still full, it's going to go through this fault cycle. I get it, this is definitely in the weeds, but that's the way that the battery controls the grid tied inverter. And again, it's kind of clunky. So this is also an AC coupled system configuration. But it's pulled apart a little bit because the multi-mode inverter that resides in that Powerwall can also be separate. So you could have a Snyder Electric XW Pro, you could have an Outback Radian, you could have a Solarc, you could have any inverter that is capable of AC coupling, do this AC to DC conversion and help charge a battery. And again, for the most part, it's going to use frequency shift modulation to turn the one trick pony grid tied inverter on or off in a battery backup scenario. Now, kind of the more historically used configuration in off-grid and robust battery backup scenarios is a DC coupled system. And the idea here is that you're using a charge controller to take the DC power from your solar array and directly distribute that to the battery bank. The benefit there is there's less conversion loss. It's a DC to DC conversion, as well as charge controllers are much better at controlling the charge of the battery. Their one goal in life is to make sure the battery is not overcharged, and they can do that very well with MPPT tracking, maximum power point tracking. So if the battery is full, the solar array doesn't have to just turn off like a grid-tied inverter. It can actually throttle itself back and allow the solar array to produce whatever your loads in the house are using while keeping your battery tended. So it's a much better way of getting more out of your solar array than an AC coupled system is, because it's not a clunky on, off. It's a very gradual throttling of solar input. And then in a DC coupled system, you also need a multi-mode inverter. But because the solar array is separate from the AC side of things, it's much easier to integrate a generator. So because the solar is charging the battery in DC, that's kind of on one side of the equation. If the generator wants to charge the battery or charge loads in the house, it can do that simultaneously, much more elegantly than, let's say, an AC coupled system. And then kind of in today's modern day and age, this is becoming more, the DC coupled system is becoming more familiarized by the hybrid inverter, which is both a multi-mode inverter, so it can invert power from DC to AC, a charger, so it can take AC, distribute it to DC to charge the battery, and then it also has an integrated charge controller as well. So it's kind of an all-in-one solution that can be paired with an array of batteries. And the cool thing is that there are many options on the market as far as batteries. And for the most part, the industry standard for batteries is 48 volts with most hybrid inverters. I'm going to talk very briefly in a few minutes about one of those options. But the idea is that with a hybrid inverter, you are making the most out of a DC coupled system while still having the ability to grid tie and interact with the grid very easily. So for me, I would say like a really important part of having either a hybrid or DC coupled system is making sure that the inverter and the battery and the charge controller are all speaking the same language. In past years, inverters and charge controllers had deduced state of charge SOC of a battery. How charged is my battery? By things like voltage or shunts or amp input output. Nowadays, a new industry standard is the closed loop communication. So essentially, there's an Ethernet cord plugged in from your battery directly to your inverter, and the battery is telling the inverter and the system at large how charged it is and how willing it is to accept charge or to discharge. So because of this very succinct communication between the devices, they can perform well beyond expectations. Another cool thing as well is that when you do have closed loop communications, you can make use of opportunity loads. So let's say it could be in an off-grid scenario or in a battery backup scenario where the grid is not present and your batteries are full. Instead of throttling back the solar array, you could charge your car, or you could turn your heat pump on, or you could use a larger load than you may normally as an opportunity load to use that solar PV for good. Having closed loop communications in a very defined state of charge of your battery is a really important aspect of this. So I'm just going to kind of briefly talk about the Solarc 15K and some of its benefits. This is kind of considered a hybrid all-in-one inverter. It has 15,000 watts of output capacity when either off-grid or in battery backup mode, meaning when the grid is not present, which equates to about 62.5 amps. Typical households in Vermont and New Hampshire are either 100, 150, or 200 amps. 62.5 amps might not seem like a lot, but your average household, depending on what you're running, is probably using 200 to 600 watts continuously throughout the day. So that is scratching the surface of 62 amps. Your Solarc, again, can take DC power using its integrated charge controller, distribute that to the battery. It can also AC couple, but I would suggest, because of many of the pitfalls of AC coupling, if you have a charge controller readily available in this unit, to opt for using a DC coupled approach. It can hook up to any 48-volt battery. It can hook up to lead acid batteries, lithium ion batteries, lithium iron phosphate batteries. Any battery essentially that's 48 volts on the market, it can interact with. Again, my preference is a battery that can speak in closed loop communication. One of those batteries being the Fortress Power eVault Max 18.5. So 18.5 is its total energy capacity. That's in kilowatt hours. The manufacturer suggests that you discharge to a level of no less than 20%. So effectively that 18.5, 80% of that's around 15 kilowatt hours. You can parallel multiple batteries to reach your kind of desired battery bank size. And to be honest, 15 or 18.5 is a large increment on the market. Kind of the smaller size is either like 3.8, 5 kilowatt hour increments. And I guess technically on the larger side is about 20. So 18.5 is on the larger size of battery increments. This battery speaks directly to the Solarc, but it could also speak to a number of other multi-mode inverters as well in closed loop communication. Lithium, I guess historically in the past has gotten a bad rap because of fire safety. There had been issues people were raising about, hey, look, thermal runaway is a serious issue. Luckily now there is a new industry-wide standard called UL 9540 and 9540A that essentially have tested the thermal runaway capacity of these batteries and make sure that they're not going to self-propagate and cause a structure fire. So it's really important when you're looking at components that you see this listing. UL 9540 is an important listing. If you're looking at a battery that does not have that listing, I would personally, look for another option, because I don't think, that would be a good fit. It's a really important aspect of home energy storage, is making sure what you're installing is listed and is safe. Most importantly, is safe. So this is a picture of a recent installation I've done. This is an eVault Max with a Solarc, and then just kind of the switch gear on the side. There's a manual transfer switch, a loads panel, and this off-grid site actually had a generator, so that's a generator disconnect on the right. I've probably installed about 100 of these things, some in off-grid applications and some in residential applications. And they seem to be a really good fit. And one of the benefits, other than closed loop communication, really efficient, effective power distribution, is also monitoring. So you can check in on your system throughout the day, and you can see some really cool graphs about what your solar array had done that day. If there was a grid outage, you could see that relayed as well. But there's a bunch of information to kind of get a better idea of maybe how much load you're using and how well your system is performing. So another really cool aspect of the system. I would say another really important aspect of energy storage on the residential level is smart load management. This is going to play a huge part in the way, kind of in the direction the industry's going, in making things more energy efficient. It's great that we're installing heat pumps. It's great that we're installing EV chargers. Those are large loads. So if we can control those loads and tell them when to turn on in ideal situations, we're going to be saving power, the homeowner money, but we're also going to be cutting down on our carbon emissions. If we don't have to rely on the grid to charge our car, that's one less kilowatt hour we're purchasing. And it's going to allow for a more resilient, robust system in general. So there's different approaches. Lumen has kind of a retrofit smart loads management system for your home. And SPAN is another example of kind of a whole home energy management system that's kind of for a new installation. This is your essentially critical, or your main distribution panel in your home. And then I think just keeping in mind that energy storage is really important, and it's really important that it's done well. The National Electric Code is NFPA 77. It's also called that's National Fire Prevention Association. So like the real goal of National Electric Code is to prevent fires and make sure that installations are safe. So personally, as an electrician, as somebody who's dedicated to this craft, I think using reputable installers and making sure that things are code compliant is paramount, because we want to make sure this industry is healthy, that it's not getting a bad name from hot wire DIY installations, and that things are safe for the end user, the homeowner. And that's it for me.
Well, thank you, Chris. That's a lot of information to try to digest. I'm sure we'll be hearing more from you later on this evening. Well, Brian, I want to thank you again for coming tonight, and also congratulate you on being the first CEO of the New Hampshire co-op. It's kind of very nice that we have our own statewide public utility, so to speak.
Well, thank you, Steve. And that's CEO of Community Power Coalition of New Hampshire. And I really want to thank Plainfield and Cornish Energy Committees, because this has already been a pretty cool webinar. So I'm glad that you guys asked us to be here. I hope that everyone's seeing my screen okay. Yeah, okay. So a little bit about Community Power Coalition of New Hampshire. We are a community-controlled nonprofit default power supplier, which means you can choose us to be your default provider of energy in your community. We've got 1 county and 43 municipal members already in the state of New Hampshire, which is almost 30% of the population. So it's a pretty impressive start. We're really happy about that. And thanks to Plainfield for being a member. We've got a lot of communities that are inquiring about becoming a member and joining CPCNH. On the right, you'll see the state of New Hampshire. We've got some folks that have launched on the right. You'll see the green is launched, and approved is folks that are members and getting ready to launch. And then we have folks that are planning on also becoming launched. And when I say launched, what I mean by that is folks that are actually taking energy from CPCNH. Roughly 214,000 folks with 90,000 accounts are already being served. We hope to launch about 30 plus members in 2024. And that would make us the 2nd largest default service provider in New Hampshire. And it's really providing some good savings for the ratepayers in New Hampshire. We're forecasting about 21 million in customer savings and community reserves expected by the end of the year. And importantly, all New Hampshire cities, towns, and counties in the state are invited to join. So please give a call if you're interested. I have a couple slides at the very end, which I'm not going to go through, but the slide deck is available that explains a little bit more about CPCNH. But let's talk about bidirectional EV charging opportunities. I'm going to talk a little bit about something called transactive energy rates. That's just a term. What that means is time of use rates, hourly time of use rates. But by taking the cost of energy and the value of energy and moving it to more of an hourly or a time of use type standard, you can really unlock the potential of storage and help spur adoption rates. And I'm going to talk about storage as an electric vehicle as a storage opportunity, because when you think about an electric vehicle, it's a big battery with wheels. It's a very big battery with wheels. I have a quote on the right by a gentleman called Michael Joist from Volkswagen. This was a little over a year ago. But it just really highlights the amount of storage that's going to be out there, because there's a lot of folks that are buying electric vehicles. And he talks about having between 2025 and 2030, 1 terawatt hours worth of storage. And I didn't check his math on this. I'm just taking it from something he quoted on. But he's stating that that's, more energy than is currently generated by all the hydroelectric power stations in the world, which that sounds like a pretty big task. So even if he's halfway wrong, it's still a lot of energy. The point at the very end of that sentence or that quote is that these companies are really going to be looking at that energy. It's a lot of energy that's out there that's being stored. They're going to look for ways to use it. And I'm going to talk through a way to use that energy. So EVs have really large batteries. I did a little research on it, and it's right now, I guess the average battery size is around 69 kilowatt hours. So that's the same size of 5 Tesla Powerwalls. And we talked about that already. EVs are becoming more commonplace. ISO New England, which is the grid operator for New England, they're keeping a really close eye on this, right? Because you need to serve, in order to provide a new fuel, electricity, to the transportation industry, you really need to know how quickly is it coming. And when they took a look at this, they changed their estimate already from 2022, and they increased it by 110,000 vehicles in 10 years. They're up to 2032 in New Hampshire alone. So it moved up to 166,000 vehicles in New Hampshire. So they're expecting New Hampshire to have a decent amount of EVs out on those roads. And in the first few years of this estimate, and again, it's just an estimate, it could exceed it or could not meet it. But they're expecting the amount of folks that are buying EVs to double each year, roughly. That means there's a lot of need for energy coming. 3,400 additional megawatts, which is a lot. And I put 13% in there in parentheses to give you an idea of how much of the total of that need is. So in 2032, 3,400 megawatts represents 13% of the entire need for storage or for generation in the region. So 13% of the actual need is coming from the transportation sector. So pretty significant. What are we going to do about all this? An accurate price signal can help us mitigate the overbuild of capacity and transmission. So when you have that many megawatts, you could build plants for that. You could increase the amount of transmission that's out there in the system. You probably will still need that, but if you do kind of a everything above strategy, you may want to also send proper signals as to when you want to charge those batteries in your EVs and when you may want to discharge those batteries in those EVs and help provide grid services. It can help to make the grid a bit more efficient. On the right here, I've got an example from New Hampshire Electric Cooperative, who's running a transactive energy rate pilot right now. On the left-hand side, their left-hand axis, which is right here, I'm not sure you can see this or not, but it's showing what's the price per kilowatt hour. And you can see from the top bar here, it's saying the lowest price in this one day, this is hour ending 1 to hour ending 24, or really from midnight to midnight. It's all 24 hours of the day. The lowest price per kilowatt hour was 3.6 cents. And then the highest price, which is sending a really strong signal to either not use energy or to go ahead and discharge energy if you have that capacity to do that, is $4.45 a kilowatt hour. Humongous difference. So if you were to sell your energy into the system, you'd be making $4.45 for doing that per kilowatt. This will help smooth out the flow of electricity in the overall system. So the reason these prices are so high at this point is because there's a real constraint on the system. There's a need for additional energy, and if you can inject it at the right time or stop using it at the right time, then it makes the system work a lot more, much more efficiently. So that's the transactive energy rate in a nutshell. What does this mean to folks that are able to just charge? So this is just lowering their charging costs. So this isn't the bidirectional side. This is just charging for low hours and not charging during these really high costly hours. The charging costs are about $1,800 a year in savings versus an internal combustion engine car, a regular gasoline operated car. And that's been talked about a lot. It's just a little bit, it's much less expensive to operate an electric vehicle for fuel. I have a little note here that these little hyperlinks go to a video about this, and that's where it starts talking about this, is at minute 27. But if you add bidirectional capability to this, and you go ahead and allow that EV to also discharge its battery into the grid or into the distribution system, you can really increase that amount for a family each year. $3,300 a year. You're looking at almost $300 a month. That's a lot. That really helps add to your overall benefit or balance out the family's budget. Now, this is not something that's way down the road. Plymouth State University is doing this right now. They helped New Hampshire Electric Cooperative prove out this pilot. They're doing it with a Nissan Leaf, and they're a Fermata Energy bidirectional charger. So you do need a special type of charger to do this, which allows you to not just charge from the grid, but also to push back into the grid. And I've added a couple estimates on how these calculations were done. Okay. On the right, there's a quick example of what that looks like for a hourly price. I had talked about it a little bit. This is not a real-time price, so you don't have to be sitting there by your computer and checking to see when the price is right and then going ahead and charging your car. That's not very practical. This is something you can be done the day before. So in this example, this is New Hampshire Electric's transactive energy rate pilot. They put out a day ahead price, and you can go on their website now and see what that day ahead price is already. And in the example with General Motors, we worked with General Motors, or I could talk about the Plymouth State example as well, but that signal gets pulled in by General Motors software. And when they go ahead and help decide when is the best time to go ahead and charge that vehicle based on the pricing that they received from the day before. So the member or the car owner doesn't actually have to go out and schedule their car. Same as the example with Plymouth State, Fermata Energy, which is the company that developed the bidirectional charger. They pull in the price and they send a signal down to the charger to decide when to either charge the Nissan Leaf or discharge the Nissan Leaf. These hour endings, that's just the hour of the day. And these are the different prices that you see. And in this example, you're taking the cheapest prices during the day and you're deciding to charge your battery. And then in the highest cost hours, you're deciding to discharge your battery. And there's a difference there. Now, there's a lot of EV manufacturers that are producing bidirectional cars. They're producing them right now. So Hyundai and Genesis, they have multiple models. Kia's new 2024 models are ready. Nissan Leaf has been doing it for quite some time. And the Ford F-150, you probably remember seeing that Super Bowl commercial. So that was an example. And GM is planning to have 6 models in 2024. So quite a few models ready to go. Volkswagen's ID platform. So they have some cars. I think that's the Buzz ID, actually, which is like the van. And then Volvo is also reporting to do bidirectional capability soon too. So there will be options out there. There's not a lot of the bidirectional chargers that are available. So you have the cars, but there's not a lot of bidirectional chargers in the US that are available. There's a couple more in Europe that I didn't talk about. But one that is coming is made by a company called Wallbox. And the unit is called Quasar, and that will be working with the Hyundai units. But Fermata Energy has one right now, and I think Volvo is working with those guys as well. Nissan does work with them too, and their unit's called Fermata FE15. So that's my discussion on transactive energy rates. You can go ahead and move that along, Steve.
Well, so just having your car parked in your garage during dinner time can pay for the usage for the rest of the day and probably power part of your house as well.
Yeah, and help solve some grid problems at the same time.
That sounds, yeah, I think with all those links in this presentation, there'll be a lot of more information that we can get. Very interesting. Well, Tony, I'm going to leave it to you now to kind of like tie things together. You can kind of allude to your spreadsheet. I'm sure just talking about the batteries will bring a lot more questions into people's minds. So we can go ahead with your overview, and then we'll open it up for a discussion.
Yeah, thanks, Steve. Not really sure where to begin. I know where to end, 8:30. So anybody has any questions for me, that's great. This spreadsheet is designed mostly for the do-it-yourselfer installer type. So I list the voltage of the battery so that you can select equipment that's compatible. I list the price of the equipment, but the price can be very misleading. In the case of the Tesla Powerwall, the inverter is built in, but the inverter has limits until you get to Tesla Powerwall Plus, where you have the inverter with 4 MPPT, and it looks to me like that's not available till 2024. But according to one of the speakers, it's available now, so I'm not sure about that. But it's the battery inverter conundrum is huge. I guess we got about 18 lines, 18 different product offerings that are available, and Revision covered Tesla Powerwall and SolarEdge. Catamount covered Fortress, eVault, and the Solarc inverter. Solarc also makes a battery that I believe is recent, and I'm quite sure it's compatible with the Solarc inverter. So those are all options. Tend to be pricey. The least expensive way to do this is to buy components that are matched and put them together. I favor the all-in-one inverter. I believe that, let's see, Chris Sparadeo, I believe he called it the hybrid. Anyway, I call that thing the all-in-one because it'll take solar DC input and battery input and AC input, keep the batteries charged, keep the critical loads running. And those to me are the important functions, and the fewer boxes that you have, I think the better off you are. I'm not in favor of separating the controller unless you have extra solar input that you want to manage. So I really favor the all-in-one, which is Solarc, EG4, and I'm not familiar with all the inverters in very close detail. But you really can't talk batteries without talking inverters. So if you, for example, if you buy the SolarEdge battery, it runs at 450 volts. And the only thing I found on the whole market that's compatible is the Energy Hub inverter by SolarEdge. So yeah, I mean, it's top of the line, but it's unique. Another system out there is SMA, but they require a 400 volt battery that's only made by LG Chem and one other company. So I try to stay away from anything that is unique or outside the 48 to 51 volts. You end up with big cables, but you end up also with easy matching components. And that's what I find the most useful. Canadian Solar just came out with a system that looks really, really good. It's called the EP Cube. And in terms of reputation and power, reliability, I'm not sure about UL Listing because they're Canadian. They have a different nomenclature in Canada, and I'm not sure what it is. And the other ones, I think I mentioned EG4 because it's all-in-one inverter and they sell the batteries and it's affordable. You can get a nice 10K EG4 set up for a material cost of 7,000 or 8,000. You know, 10K with a all-in-one inverter. 7,000 or 8,000 would include the critical load sub panel and some other stuff. And anybody that's doing this, I do recommend that you create a critical load sub panel so that your AC output is isolated to that panel. You do not want your AC output anywhere near the main service panel. You run into all kinds of problems. This off-grid stuff is not UL 1741. Well, it complies with UL 1741 because it does not feed the grid. So because it does not feed the grid, you must have a critical load sub panel. I think that's the best way to say that. Another one that looks really good is Generac, comprehensive solution. Sonnen I've heard bad things about, so I'm not gonna, it's on the chart, but I'm not thinking it's so great. Now, one of the guys at Catamount, I believe, or SolarFlect, no, not Catamount, SolarFlect, David Lutz has, I believe, indicated that Sonnen is now not part of their offering. I think they had problems, was the story. So I'm not, you know, it's on the chart, but I'm not going to recommend that one. And the minor players here, like Trophy and Simplify, no, not Simplifies, should be a major, but it's not. But things like Trophy and Rich Solar and EcoFlow, they're secondary and they're highly competent and there's nothing wrong with them. It's just that you won't find an installer who will put them in. None of the major companies are going to touch the secondary stuff. So the other thing is, my experience with the installers is that they want to focus on equipment that they trust, and they don't tend to stray very far from a base offering. So this spreadsheet is meant to inform the buyer what they get and what it's compatible with. And when they're listening to an installer, such as the ones you've heard tonight, they have some basic data to compare with other systems, other costs. And the cost comparisons are extremely difficult because the equipment varies all over the place. One of these things, the Tesla Powerwall Plus, has 4 MPPT, and the EG4 only has 1. So how do you compare cost? And so, some of them have the battery built right into it, like the Powerwall. I mean the Powerwall Plus. The Powerwall 2 is a standalone battery, and you have to get a separate system to incorporate the solar. Anyway, I think I didn't cover Enphase because that's quirky. They have an IQ battery inverter, which is unique to them, and their voltage is 67. So Enphase is extremely reliable, excellent service, but they're really in a unique niche. They are not, they're not compatible with anything else. So nothing wrong with that. It's just makes it hard to fix something or, service and that sort of thing. So that does it for me.
All right, Tony. Well, thank you. I just wanted to make my own quick observation that that spreadsheet had a pretty complete list of all what I look at as square batteries. And I can't help but thinking what Brian was saying about all those other batteries on wheels that could be other options. But that's my 2 cents. And I want to hear from everyone else now. So we'll take questions from the participants. I see Emily already has her hand raised, and there's a couple of other people. So we'll just try to answer your questions in order that you've raised your hand. So yeah, Emily, you're connecting, and I think we'll hear from you in a very shortly. Okay, Emily, can you go ahead?
Oh, great. Sorry, I had to switch my connection here. My question was, I'm trying to help some elderly neighbors through some energy thinking, and wondering about whether a backup battery system could make sense kind of in lieu of a generator for a house that doesn't have solar and where they don't have an EV. Is the technology kind of there yet, or is that really not in applicable use?
I think I can maybe speak to this. Thanks for the question, Emily. Yeah, you can absolutely integrate a battery into a home system without PV or without an electric vehicle. The idea being, if during an outage you don't have a charging source, you're confined to the battery capacity. So if your battery capacity is sized to get you through a certain amount of time, kind of analyzing the house's general energy consumption, then that could be a great fit. A generator is definitely probably a cheaper option that could potentially get you through a longer outage. But a battery could be a nice fit as well. So I would say that could definitely.
Yeah, thank you. Nora, do you want to unmute yourself? There you go.
Thank you. I've got a question for Brian. I wondered whether there's any information about how bidirectional charging affects the longevity of an EV's battery system. Because I understand it's a ton of money to replace your EV batteries. And if this is accelerating the need for that, then that needs to be factored into the cost.
Yep, I hope you can hear me okay. So the answer for that's a question that's come up quite a bit actually, and I can use Nissan as an example. So Nissan is standing behind their battery warranty. So they've got that right in their kind of their user's manual and says that, well, I think it's 10 years and I think 100,000 miles, I believe. I got to double check on that, but it's in there. It's actually in their user's manual, so you can look at that. But they're standing behind their battery is that whether you use that battery for transportation or you use that battery to help provide grid services or to run your home for it, they're going to still honor that.
So then it's going to be by model details, in the case of a Bolt, I don't know if they address bidirectional charging.
I was talking with a representative from General Motors just yesterday, kind of prepping for this example, for this presentation. Their first model that will do bidirectional will be their Silverado. But the same answer on that one is it's supported and their warranty is not going to be different if you decide to use it for non-transportation use.
Oh, okay. So the bolts will not be applicable to this technology, VTG.
It may be. I tried to get that answer directly out of them because I have a Bolt, but they didn't give me that answer. He says it's possible in 2024 that they could go ahead and turn that on, and that it may be a software fix or a software setting. So you might not have to do anything to the car, but the vehicles that do, if you click the link that's in the presentation that I have, it talks about the Equinox, which is a lower cost EV that's coming out in 2024. The Blazer, they have the Silverado, they have the Cadillac Lyric, and then I think there's another model or two, but the Bolt was not on there.
Thank you.
Okay, John?
Yeah, thanks. By the way, the Bolts are a different battery platform than the rest of those that you described. So the Ultium platform, which is all the ones you mentioned lastly, and the Bolts are not. They're pre-Ultium, so they're a whole different animal. So I don't think you're going to see that same compatibility. Because I have a Bolt too, and a great little car. I also have a Rivian, and Rivian works, will work with it, I'm told by the manufacturer. But again, it's the technology for this which doesn't exist. But here's my question. I've got a 12-year-old battery backup system with adjusted glass mat batteries, Outback, the controllers and converters. It's worked wonderfully. Just got through a 2-day outage. My problem is that the batteries are now 12 years old and the voltage is low, and I'm not sure how much longer they're going to last. And I have called over a half dozen contractors, and no one will help me replace my batteries. Now, I'm even willing to replace the controllers, because here's the problem. The controllers are set up for the adjusted glass mat batteries, which 12 years ago were the state of the art. Now everything, as we know, is lithium. So I'm fine with changing the controllers, changing as much of the hardware as I need to. I have the separate load panel. It's always, code compliant. And I'm a little leery of some of the lithium batteries. Nobody made a comment about the fact that the Tesla Powerwalls are a battery technology that seems to be more or less susceptible to fires, but obviously they've managed to not have that problem, whereas the lithium iron ones don't. So I've done a little homework on this, but at the end of the day, I wish I could find a bloody solar contractor that would serve me and give me a new battery bank, so that I can continue to have wonderful power during outages, which has worked really well. Because the default is to go back to old battery technology and hope my old electronics just keep ticking for another 10 years. And that's kind of becoming my default choice, which I'm thinking I'm prepared to pay for a new controller. And I'm hoping that somebody out there might be inclined to service them. And it's too bad. And one of the contractors on here, I've spoken to them, and I wasn't their customer originally, so they can't help me. So I don't know, just saying, it's really too bad, because this works. I mean, I can testify that 12 years of no power outage problems and the most recent one was 2 days and it still worked, but I'm just worried those old batteries aren't gonna last forever.
Hey, John, thanks for your question and comments. You can reach out to me directly and I can help you out. We do this kind of thing all the time. Battery upgrades, you know, moving from lead acid to lithium iron phosphate. It's pretty commonplace nowadays, especially with older battery backup systems. So I'll give you my info and feel free to reach out and we'll take care of you.
I look forward to that, Chris. Thank you very much.
Absolutely.
Diane, I think you're up next.
Okay, hi, this is Diane Folds. I'm in Windsor, Vermont. I want to go back to Brian. I have another question about bidirectional batteries. I have a Nissan Leaf, and I hear that the Japanese have been using wall boxes and bidirectional power for quite a while. So I'm wondering what's taking the United States so long to get these wall boxes, or from out of whichever brand that you end up with. Especially since they could do the job of a power wall, you know, at least for short grid outages. And secondly, after you've answered that, I have another question about power stations. This is a sort of a portable big battery that you could use again for short grid outages. And no, I'm hearing no mention of these, and I wonder if they have a role to play.
So Diane, I don't know why it's taking so long in the US to do it. And kudos to the New Hampshire Electric Cooperative for trying to help kickstart that. There are pilots that are going on around the country. And one of the ones that's most exciting is, I think the co-ops one's quite exciting. But if you think about the technology and apply it to school buses, there's a lot of excitement around that, because if you think about a school bus, there's plenty of charging opportunities, and the bus batteries are quite large. So that might be one of the main areas where we see that kick off as much faster.
So, and if could you give your opinion about charging stations, or is anybody, maybe Chris could give, or one of you, let me know, are they just too small to enter into the conversation? Is there some reason that nobody's talking about them at all? There are a ton of different brands on the market.
So I know locally in Vermont, there's a company, Core Power, Core Solutions, and then there's another subsect of that company called Nomad. They do kind of mobile autonomous charging stations, and they're doing it really well. And it's exciting, and you know, as a Vermonter, it's cool to see done locally. So it is something that's being talked about, and that is totally somewhere the market is going.
Okay, here's, I don't stations, but yeah, power stations, these suitcase type things, they're the size of a shop vac that you charge up, just sticking them in when everything's fine and you're on the grid. And then when the grid goes down, you can use this thing to plug in whatever you need, your electric kettle, your you know, your light or anything, even something bigger. And it's just not too many people seem to know about them, but they do charge up whole, I don't know, trailers and lots of things for short periods.
Gotcha. Yeah, sorry, I misunderstood on the scale. I was talking about industrial autonomous charge stations, and now we're talking about very small charge stations. Got it. Yeah. So there's a few on the market. Yeti has a goal zero option. Blue Eddy has a few offerings as well, but they're specific to a market, right? So they're typically limited in their power output and capacity, but they're also a little more accessible, from a price standpoint. But I think that they could be a fine fit for like a backup scenario. To say whole home backup, probably not, but specifically kind of very basic but important things you need backed up in your home during an outage, yes, that could absolutely be a fine fit.
Thank you, Diane, for your comments. Rangi?
Yeah. So I'm just wondering, when the community power cooperative came online, I'd love to be on it, but I've got solar that's in the old net metering world, the one-to-one net metering world. I don't know is that going to change at any point? I'm on Liberty Utilities. And then, because I asked him about, going on to time of use rates. And they said, well, if you do that, then you're basically going to get wholesale for your solar, which I said, well, forget that. So is there a way forward for me to take advantage of like time of use rates? And, I've got a Nissan Leaf too, so I could send stuff back at peak time probably.
So Renji, we are hyper focused on that right now, and there is a technically we're not able to see what's exported from a system right now. So we have no way to actually credit anybody for any exports that they might come from their solar system, or if they were using a battery to do that export, we don't see it. There's another element that we're trying to solve, which is it's a little bit more complicated, but it just means that when the coalition gets charged to pay for the power that's being served to the Keene family, it should be also credited for the amount of energy that you've exported into the system, because you're providing kilowatt hours to the distribution system. So those are two separate issues. The first one, we think we're getting solved now. We don't get to see the energy right away. It might take a couple months, but I think families like yours would be okay if it took a couple months to get those credits that you're doing on your solar. We haven't solved the second one yet, which is making sure that the bill that comes into the settlement for the coalition reflects that same energy that's been put into the system. So, but we're still working on it. Our members are really looking forward to making sure that net metering can work. But the nice part about that is once we solve the solar PV net metering concerns, we can bring in innovative rates like I talked about with the transactive energy rate. Because if you think about the meter just as a bidirectional meter, it doesn't matter what produced that kilowatt hour that's being put into the system. We just need to know how much it was. So then you can start putting much more innovation and helping to balance out the need for the capital that's going into the grid. We don't necessarily want to overbuild, and that's good for all of New Hampshire. So we're working towards it. We spend a lot of time in Concord. We focus on that to try to make sure this innovation is going to be available for all New Hampshire members.
Yeah, it's great to hear, because I think part of the problem is that, the way that utilities are built, right, is that, they can build new generation and they get, or infrastructure, and they can get that paid for, but, to make it more efficient doesn't necessarily benefit them. So I think that's maybe part of the reason that they're,
well, I think to be fair too, is a lot of when you're sending out 100,000 bills, the system to do that is sometimes pretty complicated, and it's been put in place for the last 15 years. So when you ask it to do something different, it's not always a flick of the switch. So there is that element too that we're working on.
Nancy?
Hi, this is great. Thank you all so much for these web seminars. So I have a 2019 Nissan Leaf. I'm a customer of NHEC. And I need a battery, a generator, or a battery. How long am I gonna wait before I can do this Nissan Leaf thing instead of having to buy a $10,000 Tesla Powerbook? What's the time frame, Brian? We're looking at.
Okay, I lost you. I was looking for you on the Zoom world. I would recommend you reach out to NHEC directly and ask them that question.
Okay. I mean, is there hope that that I could? This is
Yeah.
possible.
So I imagine if you're in the service, I don't know if you're close to Plymouth or not. You
No.
can go. Okay, so in
Thank you.
Plymouth, you can go to the Plymouth State University and actually see this in action. The bidirectional charger that they're using is better suited for more of a commercial type installation rather than a home installation. And the charger itself is quite expensive. It's similar cost to some of the batteries that we heard earlier.
Oh.
But that's on a more commercial scale. The one that Ford has, which is a vehicle to home opportunity or system, I think is around, I think $2,000, or it's on their website for the actual charger, which is a bidirectional charger to help serve your home in an outage. But that's just for one element of the equipment. I think there's additional equipment that's needed to be installed for them as well. And a company called Sunrun is who they've asked to do that for homeowners. And that's for the Ford specifically. You asked about the Nissan. I know a Fermata Energy bidirectional charger works well with the Nissan system. So
but you're saying we're what, a few years away from actually being able to install something like that, or?
Yeah, but I wouldn't. One way to look at it though as well is when you have those time of use rates, it's not just about discharging the vehicle's energy. It's also about charging at the right time. So you can really reduce your overall cost for charging that battery by charging at low cost hours. So there's
Brian, I'm actually not interested in doing that so much as I need a backup system, and I don't want to buy another generator, and I don't want to buy a power wall if I can use my car. So I'm trying to get a grip on when that is going to be a possibility.
Yeah, so I think it's probably best just to get in touch with your utility and see what they have to say.
Okay, I thought Brian might have a guess, in knowing the whole picture.
Well, I think we've got time for one or two more quick questions. So we are going to try to wrap up at 8:30. So Terry?
Good evening. So the previous question was perfect lead into my question, which is, there's all these idiosyncratic solutions out there, both even just the plug that goes into your vehicle all the way to the batteries themselves, the charge controllers. Is there a national electric code convergence, automaker convergence? I'd love to invest in some of these technologies, but I feel like it's a wild west that, someone was talking about, they've got this particular technology that they're having trouble replacing. It's a decade old, and what's the sort at the national level, what's the convergence of code and standards and that sort of thing? So I guess it's probably for Brian. I don't know who else may have a perspective on that, or Chris.
I'm not an electrician, so there might be a better person to go ahead and answer that one.
You mind just recapping the question very quickly?
So we've spent a lot of time looking at a lot of different systems that all have idiosyncrasies, both vehicles, the type of charger that a particular vehicle does, the charging, the battery backup systems that have talked to each other or don't talk to each other. I'm wondering if at a sort of a national level, if there's a convergence of down to the type of communications between the batteries and the chargers and the inverters, between the vehicles to the chargers and the it seems like everybody's talking a different language and using different technology. And so what kind of convergence is hopefully happening for standards and codes?
Sure. So currently EV to load is kind of pie in the sky, and we're probably a year off from any real good solution. That being said, it's coming, and it's coming very quickly. Enphase is one of the largest players in the solar field. They just recently acquired Clipper Creek, which was also probably one of the larger EV charger manufacturers in that industry. So I think the idea initially is going to be that everything is on the same native platform, because it'll be easier that way. But eventually, just like Tesla and other EV manufacturers, things are going to become universalized because it's in everyone's best interest to do so. So I think we're probably going to see specific manufacturers with specific offerings in the beginning. And then as things roll out, hopefully we're going to go to a more universal platform.
All right, well, thank you, Chris. Kelly, Joe, sorry, but I think we're running out of time. If you have some specific questions that are addressed to one of the guests, maybe you could follow up with them, or bring it up to your Energy Committee's attention. Well, everyone, thank you for attending this presentation on home battery systems. It's really sparked a lot of interest, a lot of conversation. A special thank you to our guest speakers and to Joanna Scharf of the Cornish Energy Committee for arranging tonight's event. We'll send each of you an email containing the recording of this event and the links to all the topics that were discussed tonight. And again, if you have specific application questions, you may contact any of our presenters directly, and we'll provide links as well on how do you to get in touch with them. And please reach out to any Energy Committee member for more information on this topic or on other energy related topics pertinent to our towns, and how you can get involved in Cornish and Plainfield's energy future. Again, thanks everyone, and good night.
Thank you.
Thank you so much, Brian, Tom, Tony, and Chris. Really appreciate it.
Thanks for having us.
Thank you.
Good night.
Good night, everyone.